Have you ever stared up at the night sky and felt that strange pull, that dizzying sense of wonder as you try to comprehend the scale of it all? Most of us have. And yet, when someone asks, does the universe have a limit, it's the kind of question that stops you in your tracks. What if I told you that the universe isn't just vast, but possibly infinite? Or maybe it isn't. What if we're stuck forever inside a cosmic bubble, unable to ever glimpse what lies beyond? These aren't questions reserved for scientific papers or distant observatories. They touch something primal within us, our hunger to understand not just the universe, but our place within it. Here's the twist: the limits of the universe aren't just about size or distance, they're written into the fabric of reality itself. The speed of light sets the ultimate boundary for how far we can see, while the mysterious force of dark energy expands the universe faster than we can ever hope to catch up with. It's like running on a treadmill where the finish line keeps moving further away. Frustrating? Definitely. But also a challenge, a puzzle, an invitation to explore not just space, but the deepest mysteries of existence itself. So, here's the big question: could there be something beyond the observable universe? Entire galaxies, realities, or even infinite multiverses that defy everything we know? Stick around, because we're going to dive deep into not just the universe's boundaries, but what lies beyond our wildest imagination. And the answers might just leave you questioning everything you thought you knew about existence. Ready to take this journey? Let's begin. Imagine, for a moment, that you're sailing across a vast ocean at night, surrounded by complete darkness. You can only see as far as the light from your small boat reaches. This analogy offers a glimpse into what we call the observable universe. It's a fascinating concept, isn't it? The observable universe isn't defined by physical walls or barriers but rather by the constraints imposed by the very fabric of the cosmos, the reach of light and the passage of time. In essence, we can only see what has had enough time to reach us. Think of it as sitting in the audience of a grand cosmic theater, where light takes center stage, yet the stage is only partially revealed, depending on time's permission. Now, let's make it even more relatable. The sunlight we see isn't live. It takes about 8 minutes for sunlight to travel to Earth. Knowing that detail changes your perspective, doesn't it? Now, stretch that idea over incomprehensible distances. The light from distant galaxies might have traveled billions of years before finally reaching our telescopes. In a way, gazing at the sky is like flipping through a cosmic photo album. Every star or galaxy we see is a snapshot of the past, a relic of the universe's history. This means that everything we observe exists within the limits of our perception, and what lies beyond is still hidden from view. But how far can we really see? This question leads us to the staggering figure of 93 billion light-years, the diameter of the observable universe. It's a scale so vast that it's almost impossible to grasp. Yet, what lies beyond this limit? Could there be something hidden, something intangible to human comprehension? These questions push us to the edge of our understanding, forcing us to ask whether the boundaries we recognize are real, or merely artifacts of our inability to look further. And this brings us to another key question: the role of light as our guide through this cosmic mystery. Imagine trying to send a message to a friend across an endless void, but no matter how fast you try, there's a hard speed limit you can't surpass. That's essentially the role of light in the universe. Light, traveling at an incredible 299,792 kilometers per second, or about 186,000 miles per second, isn't just the fastest thing we know, it's also the ultimate ruler of distance and time. This universal speed limit creates a cosmic horizon, the farthest edge of the observable universe, beyond which we cannot see or detect anything. Why? Because the light from those regions hasn't had enough time to reach us in the 13.8 billion years since the universe's inception. It's like being forever stuck inside a bubble, where light and time define its walls. Now, let's think about how this affects us on a practical level. Picture a galaxy so far away that the journey of its light began long before life even existed on Earth. That light has spent billions of years traversing the vast emptiness of space, just to arrive in our telescopes today. Fascinating, right? But here's the catch: the speed of light isn't just a limit, it's also a lens that shows us everything in the past, never in the present. When we observe a galaxy billions of light-years away, we're not seeing it as it exists now, we're seeing how it looked when dinosaurs roamed the Earth or when the first stars were still forming. In this way, the speed of light doesn't only set limitations, it also connects us inextricably with the history of the universe. The true mind-bender is this: the expansion of the universe means the cosmic horizon isn't static. Even as we marvel at light reaching us from the edges of the observable universe, the very objects that emitted that light might now be far beyond our reach. They've moved, carried away by the relentless expansion of space itself. The interplay between light's speed and the universe's growth is like trying to catch a glimpse of someone running away on an escalator that's also speeding up. This sets the stage for bigger questions: what drives this expansion? And how does it affect the limits of what we can ever know about existence itself? Imagine blowing up a balloon, but instead of a gentle, steady inflating, the balloon starts expanding faster and faster as you go. That's the role of dark energy in our universe. To put it plainly, dark energy is the mysterious force driving the accelerated expansion of space itself. It's counterintuitive, isn't it? You might think that gravity, the glue that binds galaxies and stars together, would eventually slow down this expansion. But instead, it's doing the exact opposite. Not only is the universe growing, it's doing so at an increasing rate, constantly pushing the boundaries of what lies within our reach. This leaves us with a strange paradox, where we may be able to observe less and less over time, even though the universe continues to expand. To get a sense of what this means, let's revisit the idea of galaxies at the edge of the observable universe. Even as their light travels toward us, the space between us and those galaxies continues to stretch. It's as if they're on a treadmill that speeds up faster than they can run. Eventually, some galaxies will cross a point of no return, where their light will never reach us, no matter how long we wait. Think about that for a second: there are parts of the universe we'll never, ever be able to know about. This dynamic boundary, dictated by dark energy, constantly reshapes the very limits of our cosmic bubble. What's within our grasp today could fall beyond the horizon tomorrow. Here's where dark energy becomes even more perplexing. While we don't fully understand what it is, scientists estimate that dark energy makes up around 68% of the total energy in the universe. Let that sink in: most of the universe is governed by something we don't even comprehend. Some theories suggest it's a property of space itself, constantly creating more room for existence to expand into. Others propose it's connected to the vacuum energy of quantum physics. Whatever the answer, one thing is clear: dark energy isn't just a cosmic footnote, it's the key player in rewriting the map of the universe. But what if there's more? What lies beyond this ever-expanding boundary? And how can we even begin to comprehend what exists outside our observable universe? Take a moment to picture the observable universe as a small island in the middle of a vast, uncharted ocean. You stand at the shoreline, staring into the endless horizon, wondering what lies beyond the waves. This is the enigma scientists grapple with when considering what exists beyond the limits of what we can observe. Is there something out there? Most theories suggest yes, but here's the twist: we may never be able to confirm it. Beyond the cosmic horizon lies a realm that exceeds both our perception and our tools, leaving us with only speculative breadcrumbs from physics and mathematics to guide us. One popular theory is that the observable universe is just a tiny portion of a much larger multiverse. Think of this as a never-ending quilt, where our universe is just one patch in a vast cosmic tapestry. Each patch could represent a separate universe with its own laws of physics, dimensions, and even different versions of existence. It's a concept as mind-boggling as it is thrilling. Imagine, for instance, a parallel universe where the fundamental forces of nature are slightly altered, galaxies might never form, stars might never ignite, or life could take on forms we can't even begin to imagine. The multiverse isn't just science fiction either, it's rooted in ideas from quantum mechanics and string theory, making it a tantalizing possibility. But that's not the only idea on the table. Another theory posits that the universe could be infinite, stretching endlessly in all directions. If that's the case, then what lies beyond the observable universe could simply be more of the same. Picture an infinite sea filled with galaxies, stars, and clusters, repeating endlessly like an unbroken pattern. Yet, there's also the possibility that the universe has a finite boundary, a definitive edge. Here, we reach the realm of the unknown. What could lie beyond that edge? Some physicists propose that it might lead to entirely new dimensions, or even something entirely incomprehensible to the human mind. These questions pull us into deeper waters of curiosity, where the interplay between science and imagination creates a boundless playground of thought. So, now that we've explored the limits of the observable universe, the speed of light as a cosmic boundary, the mysterious force of dark energy, and the tantalizing theories of what might lie beyond, what does all of this mean for you? Well, here's the thing, the universe's mysteries aren't just about distant galaxies or hypothetical multiverses, they're about challenging the way we think. How often do you let your curiosity take you to new places? How often do you push the boundaries of what you think is possible? Understanding the universe is more than an academic pursuit, it's a reminder that limits are often just the edges of what we currently know. The real question is, how far are you willing to look? Imagine applying this mindset to your everyday life. What if you approached obstacles the same way scientists approach the unknowns of space, with curiosity, determination, and a willingness to explore beyond what's immediately visible? What could you discover about yourself, your goals, or even your potential? Let the vastness of the universe be a mirror. It's limitless, expanding, and filled with possibilities. Are you? Now, here's where you come in. What do you think lies beyond the observable universe? Is it a multiverse, infinite galaxies, or something completely unimaginable? Drop your thoughts in the comments. Let's expand this conversation together because big questions deserve even bigger discussions. And hey, don't forget to subscribe to the channel and hit the notification bell, we've got a whole universe of knowledge waiting for you in our next videos. The journey doesn't end here, it's just beginning.